Okay, hello, what's up? Welcome to trigonometry session. This is our session 7. It's our part 7 where we're going to be focusing on solving problems in 2 dimension using the sine rule, cosine rule, and area rule. So in this session, really, I just want us really to look closely at past papers on how we can solve problems using the sine rule, cosine rule, and area rule. Okay, we're gonna start with this. It's taken from a past paper, and definitely we have to be thinking of those rules that we just covered in our part 6. Okay, so A, it says write down BD in terms of H and a trigonometric ratio of X. Okay, let's go and look for BD. This is our BD. Can you see? BD is on a triangle. Can you see BD? It's on a triangle that is 90 degrees. It's on a right angle triangle. So we know that we can use trig ratios in order to solve for BD, right? So we had to check what is our BD. Our BD is our adjacent. And what is our H? Our H is the opposite. Can you see? So this one is the adjacent and also opposite. So what is opposite over adjacent is what? Is tan. So we're going to say tan x is equals to opposite, right? Over what? Over adjacent. But what is your opposite? Your opposite is what? Is h, right? Opposite is h. What is your adjacent? Your adjacent is what? Is BD. Can you see? So I can just write h over BD. H over BD. So to solve for BD, because they want BD in terms of H and the trig ratio, I'm going to solve for BD. So BD multiplied by tan x is equals to what? H, right? So if I divide both sides by tan x, then BD is going to be equals to H over tan x. So that is how you can express that. So where there is this one, BD is equals to H over tan x. So that's basically how we can express it. Okay, B. Okay, as for your B, it says let me just delete this. It says write down the angle of write down the size of angle CDB. So obviously here there must be that thing to show CBD. Let's look at CBD. CDB, yeah, CDB is this one here. Can you see? They want that angle there, but you can see that angle is found on this triangle. Can you see? On this triangle here that is just shaded there and all that. So you can see from that triangle we have sides that are equal. Can you see? BD is equals to BC. It means both of them are equals to H tan x. Okay. So what's that kind of triangle? Is an isosceles triangle. What do we know? Base angles are equal, right? So we can say CDB will be equals to what? Will definitely be equals to B angle CD. Because of what? Angles opposite equal sides, right? So angles that are opposite are equal, and also this is because their sides are equal, or you can say base angle of isosceles triangle. So now I can go and solve for my CDB. How? Sum angle of a triangle is equals to 180 degrees. It means y plus CDB plus, we just lettered this one again, can see that one there, to be equals to CBD. So in its position I'll just write CDB is equals to 180 degrees, and I'll just say sum angles of what? Of a triangle, right? So let's go and solve for C angle DB. This one plus this one, it will be 2 angle CDB is equals to what? 180 degrees. I take y to the other side, minus y, divided by 2, divided by 2. Then C angle DB is going to be equals to 180 divided by 2 is 90 degrees, minus y divided by 2, minus y over 2. So that will be the size of angle C angle DB. Can you see? So that's it. Okay, let's go to C. Quite challenging. It says hence or otherwise prove that CD squared is equals to what? 2h squared into 1 minus cos y divided by tan squared x. So what do you think is the rule that we have to use here in order to prove that CD squared? Whenever you see something with a square like this, CD squared, side squared, obviously it will be what? Cosine rule. Cosine rule. Because cosine rule has something to have with squared. So why also cosine rule? Because we have two sides. We know two sides. We know that one is h over tan x, and also this one is also h over tan x because they're equal over tan x. Then we have two sides and an included angle, so we can use what? The cosine rule. What will the cosine rule say? To say CD squared will be equal to the sum of the other two sides squared. So it will be h okay, let me just write h over tan x squared plus that other side is also h over what? Tan x, then square minus 2 into these sides multiplying together h over tan x, then what? Cos angle y. Can you see cos of y because that's an included angle? Or maybe let me just write the general one here so that you may not get lost. So I'm just saying CD squared is equals to BC squared plus BD squared minus 2 into BC BD, then multiply by, oh, maybe I can put it there, cos y. So that's the cosine rule that I'm using, right? So what's left now is just to simplify here, right? So it's just to simplify, and you show them that really your CD squared is gonna be equal to that. Okay, let's go and do that. In order to simplify, definitely let's go and do that. It will be CD squared h squared over, so it will be h squared over tan squared x, right? Also here is h squared over tan squared x minus 2. This one will be h squared over tan squared x. If we multiply this and this, right? Tan x and tan x, what? Cos y. Okay, so now we can go and take the lowest common denominator, or we can group the like term. This one and this one will give us what? 2a squared over tan squared x, because there are two of them, minus 2a squared over tan squared x cos y, right? Can you see now that we have a common factor, right? Of what? Of 2a squared over tan squared x, right? It's a common factor. There will be left with 1 minus what? 1 minus cos y. Can you see? We've just definitely proven that indeed CD squared was equals to 2h squared into 1 minus cos y, because this one we can simplify it to say 2h squared into 1 minus cos y, all divided by what? By tan squared x. So it's basically the same as what we had to prove there. And you can see that we basically used what? The cosine rule. So they won't tell you when they give you these two-dimension diagrams. They will just ask you to calculate. Also, you can see that from our A, we had to use our knowledge for what? For trig ratios on a right angle to say what is our BD. It's our adjacent, and we have our opposite, so we can, because we have a right angle there, we can use opposite over adjacent, which is tan x there. So you can see, so they just need this combined knowledge, and they won't tell you clear guidance. You just need to be able to connect the question with those rules, such as in this question they just say CD squared, then we had to connect it quickly with what? With cosine rule, because we know it can be used to calculate the length. Okay, let's go to D. Okay, D, it says calculate CD if h is equals to 23 centimeter, y is equals to 150 degrees, and x is equals to 30 degrees. So if you get this last question, it's like you'll definitely get it in most of the two-dimensional problems, and it's very, very simple. It just connects with the previous question. So what you have to do, you just go and substitute whatever you are given and you solve for your CD. We know that from the previous question, we just proven that CD is equals to 2h squared. So it will be 2, what is your h, is 23 squared, 1 minus cos, what is your y, it's 150 degrees, divided by tan squared x. So it will be tan squared, what is our x, 30 degrees. Then you can just simply use a calculator to solve for that, right? So I'll apply the square root both sides so that I can cancel out the squared in CD, and just to get the length of CD. Okay, so we're gonna do like this and square like that and use a calculator to get the answer. Okay, so the answer will be 76.96. I hope this will be units. This is the length. Okay, so our CD will be 76.96, and that's it. Okay, let's just look at a different problem. Okay, let's now look at this example. You're given two triangles there. They're telling you that AC is equals to BD, and we can see that our AC is being equal to BD because both of them are equals to X there. And you're given that B angle DC is this one. It's equals to 90 degrees minus alpha. Okay, so they're saying prove that CD is equals to X over tan alpha. So they want you to prove that really CD here will be equals to X over tan alpha. Can you see your CD? It's on a right angle triangle ACD. Can you see it? It's on this right angle triangle. It's quite similar to the first question that was there on the previous example, but it's just that here they're just asking you in a different way. Can you see? So that's what they mostly do. So, and you can see that they just express CD in terms of trigonometric ratio with alpha and also X, and you can see we have X there, and we can also express CD in terms of that. So we must first know our CD is our what? Is our adjacent, and our X is our what? Is our opposite. So we have opposite over adjacent. We know that it's gonna be what? Tan alpha. So to solve for that, we'll say tan alpha is equals to, what is our opposite? Our opposite is what? Is X. What is our adjacent? Our adjacent is CD. Then we can cross multiply and solve for CD. So it will be CD multiplied by tan alpha is equals to what? X. So to solve for CD, what do? We divide both sides by what? By tan alpha. So when we divide both sides by tan alpha, that is our final answer there. CD is equals to X over tan alpha, and you just proven that thing. So this first question are really quite very easy to solve. Okay, let's go to B. Okay, for B, now you know that your CD is what? Is X over tan alpha. So I'll just put it there. So for number B, they're saying show that BC. Can you see BC here? Show that BC, or maybe I can use a different color to highlight that. Here's your BC. They're saying show that BC is equals to all these things, and we have a square root and all those things. Okay, so how can we show this? It means, in other words, they want you to calculate the length of what? Of BC. Okay, so you can see that from a triangle here, a non-right angle triangle, you already calculated CD, and it's X over tan alpha. You are given the angle there is 90 degrees minus alpha, and you're also given this side is what? Is X. Can you see? So you have at least two sides and an included angle. What rule can we use to calculate the length? The cosine rule. Why can't we use the sine rule? It is because the sine rule is used when we have two sides and an angle that is not included. But in this case, the angle is included and we have two sides. So we have to use the cosine rule. Can you see? So that is why. So how are we going to use the cosine rule? We want BC. So it's going to be BC squared is equals to what? Is equals to CD squared plus what? Plus BD squared minus 2 into CD multiplied by BD, then multiplied by cos of what? Cos of the angle that is corresponding to BC, which is, you can see it's D. So I can name it to say it's B angle DC. That's it. Okay. So we can now go and solve for our BC. So it's BC squared is equals to, what is our CD? Our CD is X over what? Over tan alpha. And this is squared, right? It's squared. So plus BD is X squared minus 2 into, what is our CD? X over tan alpha. What is our BD? It's X. Then cos of what? 90 degrees minus alpha. Can you see? We can now simplify this to say X to be X squared there divided by arc tan squared, tan squared alpha plus X squared minus 2 times X, it will be minus 2X squared over tan alpha. Then what is cos 90 degrees minus alpha? We know that 90 degrees minus alpha, it's on the first quadrant, and on the first quadrant we have all of them. It means the answer must be positive. But because 90 degrees is a co-function, I think co-ratio, something like that. So 90 degrees will change cos into what? Into sine. So it will be sine alpha there. Can you see now? Okay. So after doing this, how can we solve this now? We can go and take the lowest common denominator. Can you see? I'm just going to do that. I'll take the lowest common denominator. Or what I can actually do is, let me just first start by taking the lowest common denominator once. Okay, so the lowest common denominator definitely will be tan squared alpha. Then I'll multiply this lowest common denominator with the first term there. Tan squared and tan squared will cancel out each other. Then on top I'll be left with what? With x squared. Plus, when I multiply this with my x squared there, then it's gonna be x squared tan squared alpha. Then when I multiply my tan squared alpha with this equation here, then my one of the tan here, tan alpha, will cancel with one of it there, and we'll be left with what? I'll be left with minus 2x squared sine alpha multiplied by what? By tan alpha, because one of them is going to cancel out each other with this one down here. So because it's squared here, can you see? Okay, so after doing that, what can we do? I can simply apply the square root to solve for my BC, right? So I'm going to apply the square root on that equation. It's x squared plus x squared multiplied by tan squared alpha minus 2x squared sine alpha multiplied by what? By tan alpha. Can you see? All divided by what? Or I can separate the square root to say it will be the root of this one divided by the root of what? Of tan squared alpha, just to make that fast there. Okay, so BC will be what? On the numerator, I have a common factor of x squared. Can you see? We have x squared as our common factor. So I'll take x squared as my common factor. Then it will be what? Let me just put it a bit down. Let's do this. Then it will be x squared as my common factor. I'll be left with 1 plus what? Plus tan squared alpha minus 2 sine alpha multiplied by what? By tan alpha. Okay, so under, if I apply the square root on something that is squared, the square will go away and we'll be left with what? With tan alpha. Okay, my space is fully. Let me just continue. I'll just put this, let me see, somewhere here. Okay, yeah, let's just continue on that side and see how it goes. Okay, my BC is going to be equal to, can you see, now that I took out my common factor, I can use the rules about sets to say if I have things that are multiplying each other here, then I can just say the root of what? Of x squared multiplied by the root of that other one. So the space here is very small, so it's the root of x squared multiplied by the root of 1 plus tan squared alpha minus 2 sine alpha multiplied by what? I'll just delete this because there's no space here. So let me just put them like that, multiplied by tan alpha, and these are inside the root divided by what? They're being divided by tan alpha. Okay, so my BC is going to be, what is the root of x squared? It's going to be x, right? So if I simplify it first there, I'll say x divided by what? By tan alpha. Can you see? It's being multiplied with what? The root of 1 plus tan squared alpha minus 2 sine alpha multiplied by what? By tan alpha. Can you see? Let me just highlight this in yellow because it's quite complicated a bit with, it's just mixing up with those one. Can you see that we have now proven really that indeed our BC is equals to x over tan alpha multiplied by the root of 1 plus tan squared alpha minus 2 sine alpha times tan alpha. It's just that the arrangement there does not matter, but you can just arrange it in this way to see that it's the same. So basically what's really important here, you must know algebra, how you can simplify those things in order to prove this. But what was really most important is to know how you could use your cosine rule. Let me highlight it in red. How this first step here to say the cosine rule, to know that I had two sides and an included angle, then to get this side I can use what? The cosine rule. Okay, let's now look at this last example. It's the last one for this session, and I just want you to learn something from it. Okay, so you are given in the figure below, CD is a vertical mast. The point B, C, and E are on the same horizontal plane. BD and ED are cables joining the top of the mast of pegs on the ground, right? And you are given that DE is equals to what? 28.1 meter. So where there is DE, I'm just gonna write 28.1 meter. And BC is equals to what? 20.7 meter. Can you see? 20.7 meter. And the angle of elevation from D to B, so the angle there of elevation, remember the angle of elevation is measured from the horizontal to the top, so it's down there. It's what? 43.6 degrees. Okay, so you are also given that B angle DE is this angle there. It's what? Is 35.7 degrees. Can you see? That one is 35.7 degrees. And what do they want? And they gave you a condition here to say correct your answer to what? To 1 decimal place. So A, they want you to calculate the length of BD, right? The length of what? Of BD. Let me just highlight it for you so that you can see this is my length BD there. So you can see that BD, it's found on this right angle triangle, and we can use this right angle triangle to calculate length of BD. Can you see? Because we have an angle there, 43.6, we can use a trigonometric ratio to check what is our BD. Our BD is obviously the hypotenuse, and we're given the what? The adjacent. So definitely we're gonna go for what? For cos theta is equals to adjacent over hypotenuse. And you can see that most of these questions are quite less the same as in the previous example. It's like in each and every question you have to be thinking of using a trigonometric ratio to solve the length. Can you see? And you can compare this with other past papers. You can try treating as many past papers as you can, so that you can just know this trend, and you just be basically it will be easy for you to solve problems in 2-dimension like this. Okay, so on our A, we want the length of BD. We know that BD is our what? Is our hypotenuse, right? And we have the adjacent on that right angle triangle. So I can use cos theta, and my theta is what? 43.6 degrees. It will be equals to what? Adjacent, which is what? 20.7 over what? Over hypotenuse, and my hypotenuse is my what? Is my BD. Then I can cross multiply and go and solve for BD. So BD will multiply with cos 43.6 degrees, then is equals to 20.7. Then to solve for BD, I divide both sides by cos 43.6 degrees, both sides by cos 43.6 degrees. Then this one cancel this. Then my BD is going to be equals to, I can just use a calculator there, 28.6 meter. Okay, so this is my final answer for BD. So where there is BD, I'm just gonna write 28.6 meter. Okay, let's go to B. Okay, on B they want the length of BE, right? So they want you to calculate the length of BE. Let's go and check BE. And let me also highlight it, is this one. It's BE, right? So you can see that BE is on this triangle. So when you want to use cosine rule, area rule, sine rule, you must really identify which triangle, because it's very, very important, right, for you to solve these questions. Okay, so it's found on the bigger triangle there, on that triangle BED. Then what can we do in order to calculate for BE? So take a look at that triangle. We have this side is 28.6. We also have this side is 28.1, right? And we also have an included angle. So what can we use? The cosine rule. We have to use the cosine rule to calculate this length. Sometimes you might find that the angle is not included, where you have to use what? You have to use the sine rule in that case. So, but in this case, we have two sides and an included angle. We have to use what? The cosine rule. How are we going to use it? To say BE squared will be equals to what? To BD squared plus ED squared minus 2BD multiplied by ED. Then we multiply by cos of the angle that is corresponding to BE, which is angle D there. And I can just write it as angle BDE, right? So it's because of the cosine rule. Then BE squared will be equals to, what is your BD? Your BD is 28.6, right? Squared. Plus, what is your ED? Your ED is 28.1 squared. Minus 2 into 28.6 into 28.1. Then the cos of that angle on top is 35.7, right? So it's 35.7. To get my BE, I'm going to apply the square root, right? So I can just apply the square root there, rather than to write many steps. I can just apply the square root there, then to get my BE. So just going to punch a calculator and get the answer. Okay, so the final answer is going to give me 17.4 meter as my BE. So where there is BE, I can write 17.4 meter. Okay, let's now go to C. Okay, let's come to C. So C, it's quite challenging. Okay, you'll see it. It's saying calculate the area of triangle BEC. Can you see? Let me just highlight that triangle, maybe with yellow. BEC, the area of that triangle. Okay, it's a 9 triangle, so we have to use area rule. Can you see? We already have this side on top, which is BC, and we already have this side here, which is what? Which is BE. So in order to use the area rule, we need to be having what? That angle there. Can you see? So now we have a duty of calculating that angle. So how are we going to calculate that angle? So if you check this triangle here, this big triangle, if I get this angle, then I can calculate this angle there. Can you see? On the using that triangle. So if I calculate angle BED, if I get its value, then I can go and calculate that small angle there, which is my angle what? Which is my angle EBC. Then I can use my area rule. Okay, so I need to calculate B angle ED. So to calculate B angle ED, I can either use the sine rule, right? We can use the sine rule to say sine B angle ED, and its corresponding what? Its corresponding side is over what? Over 28.6 is equals to what? Will be equals to sine, I can choose 35.7 degrees on that triangle. Can you see? Sine 35.7 degrees. Its corresponding side is what? It's 17.4. Can you see? Then I can cross multiply and go and solve for my angle. So sine BED will be equals to what? 28.6 multiplied by sine 35.7 degrees. Okay, divided by 17.4. Then to get my angle, I'm just gonna take arc sine of 28.6 multiplied by sine 35.7 degrees divided by 17.4 degrees. Okay, then I can solve for my angle. B angle ED will be equals to, when I punch the calculator, it's giving me it's 73.6 degrees. 73.6 degrees. Let me just write it there. It's a bit messy on this diagram, but let me write it. Is 73.6 degrees is that angle there. Can you see by some angles of a triangle on that one, we can now get what? We can now get this angle here on this triangle here. By some angles of a triangle, we can now go and determine this angle here in red. Can you see? So I'm just gonna add all those things there. Let me just clean this thing. So I want my angle EBC, right? Angle EBC is gonna be by some angle of a triangle. I can go from 180 and subtract all those angles in a triangle, right? So I subtract 73.6 degrees, I subtract 43.6 degrees, and also subtract 35.7 degrees. And I will give my reasoning that is some angles of a triangle. So there I'm just doing it very fast to just go straight to the answer. Okay, my final answer will be 27.1 degree. Can you see? Now I have my angle there in red. Is what? Is 27.1 degree. I can now go and use the area rule to get the area of what? Of triangle triangle BEC. Okay, so how am I gonna do this? Let me just write it here. So area triangle BEC, it's this triangle here. Let me just highlight it in red so that you can see it's that one. Will be 1/2. That's the area rule. It's 1/2. Then I'll take the known side BC times what? Times BE. Then the sine of what? Of E angle BC. That is the included angle there. So this will be 1/2. What is your BC? Your BC is 20.7. What is your BE? Is 17.4. Then the sine of what? 27.1, which is that angle that we calculated there. Then you can just punch your calculator and get the final answer. Okay, so the final answer will be 82.0. So its area, it will be in meters squared. So can you see this question was a little bit challenging because they wanted you to get the area of that triangle in red, but you just knew its side to say there is 20.7 and 17.4 meter, but you didn't know the included angle there. So we had to first use the sine rule to get this angle here, and also then use some angles of a triangle on that triangle there to get also that angle. So after calculating that angle, it was 27.1. We had to go and use our area rule to now calculate the area of that triangle. Okay. Okay, D, calculate the length of DC, right? They want you now to calculate the length of what? Of DC there. Can you see DC is found on this triangle, but it seems as if we don't have the angle there, so it won't be useful to use it. So we can look at another triangle. DC is here, and it's on this right angle triangle. Can you see? On this right angle triangle there. Then we can just check our DC. It's our opposite, and we also have what? The adjacent, right? So we can use tan, or someone can choose opposite and hypotenuse to use sine. So I'll just go with tan to say tan 43.6 degrees will be my opposite, which is DC, over what? Over adjacent, which is 20.7. So I can just go quickly and get my answer for DC by cross multiplying, right? So 20.7 will multiply with tan 43.6 degrees is equals to what? DC. So DC, gonna use a calculator to get the answer for that, will be equals to 19.7. So 19.7, I think it was in meter. Yeah, meter. So DC is 19.7 meter. And it's very, very useful that after calculating the answer, just go back on your diagram and write it so that you'll be able to connect with these other questions that follows up. Okay. Okay, the last one, E, it says, this one we did it. E, it says, hence calculate the angle DEC. So they want this angle, right? So here it should be like this. The angle DEC, can you see? So they're using the word hence to show you that the previous question answer should help you to determine the answer in this question. Okay, so you have your DC there, and you also have this side, which is 28.1. You want this angle, and this is a right angle. Can you see? It's a right angle triangle. It means we are allowed to use what? Trigonometric ratios. But we don't just choose any of them in this case. We must first check this angle. How is it giving us? This one will be opposite, and this one will be what? Hypotenuse. So it's definitely sine that angle. So we're gonna say sine D angle EC is equals to what? Opposite, which is 19.7 that you just calculated, over what? Hypotenuse, which is 28.1. So we can solve for angle D EC by saying arc sine 19.7 divided by 28.1. Okay, so D angle EC is going to be equals to, I'm just going to use a calculator and see. So it's going to be equals to 44.5. So it's 44.5 degrees. Okay, so that's basically how we calculate that. Okay, great stuff. So this marks the end of our session, and thank you very much for watching. I think I will also do part 8, which will focus on trigonometric functions like the graph for sine, cos, and all that. I'll see how it goes, but I'll just come and comment on this video also to just say, okay, there is session 8, or you just see it popping up on YouTube. Watch out for it. I think I'll do it. And otherwise for today, that's it. And thank you very much for watching. Thank you for joining me. That's all for me, and goodbye.